Today we are going to learn about train your first neural network with Python. In this video, you'll gain practical skills in setting up and training a basic neural network using Python, crucial for advancing in the AI field. Welcome to our video on training your first neural network with Python. Neural networks are a fundamental part of artificial intelligence, mimicking the human brain to solve complex problems. They're used everywhere, from powering search engines to enabling voice recognition systems. Understanding neural networks is essential in today's AI-driven world. In this video, we'll delve into the components of a neural network and explore their significance in modern technology. You'll learn how neural networks process information in layers, handle various types of data, and manage learning through training algorithms. By the end of this introduction, you'll appreciate why neural networks are at the heart of AI advancements.
The first step in training a neural network is setting up your Python environment. This involves installing Python itself and an integrated development environment, IDE, such as PyCharm or Jupyter Notebook. Once installed, it's crucial to set up a virtual environment to manage dependencies effectively. This helps avoid conflicts between different projects. Use pip to install essential libraries like NumPy, Pandas, and Matplotlib. Verify your installation by running a simple script to ensure everything is working correctly. A well-configured environment is the foundation of any successful machine learning project, ensuring smooth and efficient execution of your code. Selecting the right framework is crucial for building and training neural networks. Two of the most popular frameworks are TensorFlow and PyTorch. TensorFlow, developed by Google, is known for its scalability and production-ready capabilities. PyTorch, on the other hand, is favored for its ease of use and dynamic computation graph, making it ideal for research and experimentation. Both frameworks have extensive community support and resources, but your choice should align with your project needs and personal preferences. Consider factors like ease of learning, documentation, and the specific requirements of your neural network when making your decision. Data preprocessing is a critical step in training a neural network. It involves cleaning and transforming raw data into a format suitable for modeling. Begin by loading your dataset using libraries like Pandas. Address any missing values using imputation or removal strategies. Normalizing and scaling the data ensures that features contribute equally to the learning process. Finally, split your data into training and test sets to evaluate your model's performance accurately. Proper preprocessing enhances the model's accuracy and efficiency, laying a strong foundation for building a robust neural network.
Constructing a neural network begins with defining its architecture. Start with determining the input and output layers based on your dataset. The number of hidden layers and neurons in each layer is crucial, as it influences the model's ability to learn complex patterns. Activation functions like ReLU or sigmoid introduce nonlinearity, enabling the network to learn intricate relationships. Proper initialization of weights and biases ensures faster convergence during training. Understanding these architectural components helps tailor the network to your specific problem, optimizing performance and accuracy.
Training a neural network requires careful configuration of various parameters. The learning rate dictates how quickly the model learns, with a balance needed between too fast and too slow. Optimizers like SGD or Atom help minimize the loss function, guiding the network towards better predictions. Batch size determines how many samples are processed before updating the model's weights. The number of epochs signifies how many times the entire dataset is passed through the network. Hyperparameter tuning is vital, as these parameters significantly impact the model's performance and learning efficiency.
Once the network is built, initiate the training process. Monitor key metrics like loss and accuracy to gauge the model's performance. Validation data, distinct from training data, helps detect overfitting, where the model performs well on training data but poorly on unseen data. Adjust training parameters based on these observations to improve the model's generalization. Regular monitoring and adjustments are crucial for achieving optimal performance, ensuring the neural network can handle real-world data effectively. Evaluating the model's performance involves testing it on unseen data. This step reveals how well the neural network generalizes to new inputs. Use a confusion matrix to understand the model's predictions, analyzing metrics like precision and recall. This evaluation highlights the model's strengths and areas needing improvement. Understanding these results is crucial for refining the model, ensuring it meets the desired accuracy and reliability standards for practical applications.
Congratulations on completing the journey of training your first neural network with Python. We've covered essential steps, from setting up your environment to evaluating your model's performance. Remember, mastering neural networks requires practice and experimentation. Don't hesitate to explore different architectures, datasets, and parameters. Continue your learning journey with advanced topics and resources in the AI field. Your newfound skills are a valuable asset in the ever-evolving world of artificial intelligence, opening doors to exciting opportunities and innovations.